In front of you is what? Newton's first law of motion. Newton's first law of motion. Do you know what is a SI unit of force? SI unit of a force. SI unit of a frequency is what? Hertz. Is Z. SI unit of a force is just what? Is Newton. Okay. When word is coming Newton, so you understand that Newton is just a force. Newton is a SI unit of force. Newton's first law of motion. Newton's first law of motion we are understanding. It is also said this is the first law of motion. Newton's first law of motion is also said what? As a law of inertia. Law of inertia. We will understand about law of inertia. But before that, let's understand this. First Newton's first law of motion. Okay. A body, any object. Let's say this object, this board object. A body at rest. If this is body is at rest, okay, will remain. It will remain at rest. Okay. This body was at rest. It is at rest. It will be at rest. It will be at rest. And a body in motion will remain in motion. So this body was in a rest. This body was at rest. And now another example you can take for this. For this, okay. Anybody, that is anybody which is in motion. Anybody. This body is not in motion. You have to take an example, an object which is moving. Okay, which is moving. So that object is in motion. That object was in motion. No. That object is in motion. That object will be in motion until and unless external unbalanced force will be applied on object which is in motion. So that object which is in motion will be in motion. Okay, clear? Until other external unbalanced force will be applied on this. Same for this. Same for first sentence. Object is in rest. Object is in rest. Will be in rest. Okay. Will be in rest. For example, this. If I apply my force to do with this anything I can do. So here when I will apply, it means I am applying external force. You can say external unbalanced force on this object. So this was external force, external unbalanced force. But this will be the first sentence is saying this will be in rest, and this is in rest. If nobody will apply external force, external unbalanced force, then this will still in a rest. This will be in a rest. Okay. Nothing will be changed in that, because external unbalanced force is not being applied on this object. That's why this was in rest, this will be in rest, because external unbalanced force is not being applied on this object. That's why. Okay. So this was Newton's first law of motion. Now a object is in motion, will be in motion. A object is in motion, will be in motion. This object will be in motion. So when until okay, until when somebody came and applied force on this object, that the person can apply force on this object which is in motion, so something will happen, and it happened because of somebody applied force, and now this force is external unbalanced force. Okay, nobody will do nothing with this object which is in motion, then it will be moving, this object will be moving. Okay, will be moving. Any object is in rest will be in rest, any object is in motion will be in motion, until nobody will do with this object. Clear? So this was meaning of this. Okay, clear? Law of inertia. Remember, anything is in rest will be in rest, anything is in motion will be in motion, until somebody will do with will apply force on that object. Clear? Now I told you, I said you we will understand it with this. So let's start. Inertia of inertia inertia of rest, inertia of rest. Inertia of motion. Inertia of motion. Inertia of rest, inertia of motion. Now look, what is the meaning of this word? What is the meaning of inertia of rest? It is saying, this is same will come for this inertia of rest. This in rest, this in rest, and some force will be applied by somebody. So this is in rest, and we would say this object is what? Inertia of rest. This object is in inertia of rest. Inertia of motion, it is saying, inertia of motion, it is saying object will be in motion. Object will be in motion. We have divided this into two. You can say inertia of, one is inertia of rest and second is inertia of motion. Object is in motion will be in motion until unbalanced force will be applied. Okay, and inertia of rest, it is saying something is in rest, object is in rest, somebody came immediately and applied force on that object, on this object. So here you can say this is what? This is inertia of rest. This is inertia of rest because of object was in rest, and now object in motion, somebody will come and apply what? Force. So something now will happen, something will be impact on moving object. So it happened because of somebody applied, because of unbalanced external force. Okay, something will be impact on object after applying unbalanced external force. For example, object was in rest, it is in rest, so there is no impact, object is still in rest. So when will be impact? When external force can be of living or non-living. When external force will be will be applied on object which is in motion, then there will be impact. For this, okay, this is clear. Object is in motion. Let's say there is object which is in motion. Now it will be in motion. Nobody is doing mm, someone is nothing doing with this moving object. This is moving, will be moving. There is no impact. It is moving. Nobody did nobody uh, nobody did do anything with this moving object. So there will be, that's why there will be no, there will not be any kind of impact. Impact will be there when external force will be applied on object, then there will be impact. So can we say word impact? Okay. If object was in motion, and something happened with that moving object, then we can say that example is of inertia of motion. Something was in motion, object was in rest, and there was no any kind of effect, then we can say, okay, if there is an impact on object which was in rest, there is an impact, then we can say yes, that example is inertia of rest. What about inertia of a direction? It is saying a object is moving in a particular a specific direction. It will be moving in a specific direction until and unless unbalanced force will be applied on that object which is moving with a direction. Okay, for example, this is a circle and there is object. Okay, there is object, it is moving like that. So this motion is called what? This motion, a object which is moving like this will be known as what? Circular uniform motion. Uh, because of distance are equal. Distance, you can say motion is what? Constant. Motion is a constant. That's why we are saying circular uniform motion. If motion is not constant, so then we will say that this motion is what? A non-uniform motion, non-uniform circular motion. Okay, so here motion is a constant, and now we would say it is what? Circular uniform motion, because of object is moving with the shape of circle. Now let's move on next topic. Next topic. Okay. Next topic is what? Equation. In front of you is a equation. Can you tell me answer of this question? There is a reason. There is a reason behind this question. What question is asking uh, that why do we no why are we advised to wear seat belt when we are in car when we are in car? Then why is it advised that wear your seat belt if you are in car? So why is it advised to always wear a seat belt while driving? Why? First word would be what? For safety. For safety, it is our advice to wear seat belt while driving. Yes, for safety. It protects us. Uh, it protects us when driver apply brake. When driver applies brake, then suddenly our body uh, comes like that. Comes like that. When car stops, when car is stopped by driver, then suddenly our this part comes forward, comes towards, and when we wore when we wear but seat belt, then our body does not come towards, no, does not come because of we we wore seat belt. Okay, that's why. So here from this you will observe that our body our body is in rest. Our body is in rest when we are in vehicle. When we are in vehicle, so our body will be in rest. Of course, will be in rest. Will be in rest. But vehicle will be moving. Clear? So here, vehicle is what? Vehicle is what? Vehicle is moving. Vehicle is moving. But we are in rest. We are in a rest. And now brake 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 is being applied by a driver of a vehicle. So this is what? Unbalanced force. This is what? Unbalanced force. Brake is unbalanced force. Vehicle was in motion. Vehicle was in motion. Persons who were in the vehicle were in rest. So here persons are what? Are rest of inertia. Now these persons are in rest. Brake was applied, and these were persons came towards because of in inertia of rest. We were resting like that. And suddenly driver applied brake. Then there was impact. There is impact. Impact is what? uh, person came slightly like that. Slightly like that. It happened because of object, because of person was in a rest, and external force came into picture. That's why it happened. Otherwise external force didn't come. If external force didn't come, then we were like that. We were we were in rest. If external uh, force which was brake, brake was not uh, brake was not applied. If a brake was not applied, then we were in rest. We were in rest. Okay, so from this example, we are observing what? Newton's first law of motion. Inertia of rest, inertia of, you can say, inertia of motion, inertia of direction. From this example, we are observing, we are trying to understand. Okay, so persons are in rest, will be in rest, were in rest, but suddenly driver applied brake. Brake was an external force. An external force. Person were in rest. Persons are in rest. Person will be in rest when any kind of external force, unbalanced force, will not be applied. Will not be applied. You can say brake was an external force. It was applied by the driver of the vehicle. That's why person who were in rest came into motion. Came into motion. And now opposite you can see. Inertia of rest will come into motion when external force will be applied on object which was in rest. Now object which is in motion, when external unbalanced force will be applied on object which is in motion, it will come into rest. It will come into rest. It is happening or not with this example? Yes, persons were in rest and brake was applied, and these persons who were in rest came into motion, like that. This is motion. Now vehicle was in motion. Yes, isn't it? Vehicle was in motion. Driver applied brake, and then vehicle came when brake was applied by the driver. So vehicle was in motion. And it came into rest, like that, when brake was applied. That's how inertia of rest works. That's how inertia of motion works. So answer of this question is what? We wear what? Seat belt when we are in vehicle, because we are in rest, and something will come in front of a vehicle, then of course the driver will apply brake, then we will come into motion. Our body will go towards. Okay, when we were in when we will be in vehicle then. Okay, and vehicle will come into rest. Clear? If we want that with us there should not be happened with us, then in vehicle, then of course you should wear seat belt. Okay, I hope you understood what you understood. This was interesting. Now next example. Example of inertia. The detachment of fruit when a tree is vigorously shaken. You can take an example for inertia. Apple which is with a branch, branch of a tree. There is apple. Okay, there is apple uh, above the my body. There is apple like that. Okay, this is a tree. Now there are apples. Okay, now when we will throw a stones, uh, when we will throw stones on this tree, we want what? We want fruit. That's why we are throwing what? We are throwing stones. So when we will throw stones on this, this is already in rest. This fruit is in rest. It will be in rest. Okay. But here we are applying what? External force. We are applying external force. Here, stone is being thrown by us. Stone is being thrown by us on this. So it is what? We are applying external force. This is in rest. This is in rest. It will be in rest. This was in rest. But here, when we will apply external force, then this will come into motion. So this was an example of inertia of rest. It was an example of inertia of rest. It is an example of Newton's first law of motion. Clear? Now this one is an example of inertia of rest. Second, a person is moving with a cycle. A boy is riding on cycle. Okay, on cycle. So that boy will be in motion. That boy is in motion. Will be in motion, and suddenly, immediately, he crashes. Suddenly, in front of that boy came a vehicle. Or let's just say car, vehicle, and suddenly both came to each other. Both came near to each other, and this boy crashed. His cycle with the other vehicle. So now this came into motion. Both came into rest. This both were in motion. So it is what? Inertia of motion. And after crashing, it both came into rest. Okay. So this is impact. Impact is what? Both came into rest. It is impact. Okay. Both were in motion, but after applying force, what? Both attracted to each other. No. Both were together. This is cycle. Okay, this is cycle, and this is what you have to say. So here, accident. There happened a accident with this. There happened accident. So both were in motion and both came into rest. This is what? This is this not impact? Yes, this is of course impact. So here, from this example, these fruits were in rest, but after applying external force, it came into motion. From this example, these two vehicles were in motion, but when both came near to each other, and then happened what? Then accident happened with both the vehicles. Both were in motion and both came after happening accident. Both came into rest. This was an example of inertia of motion, and both are examples of Newton's first law of motion. Clear? Now next. So this is the next question. It is the same. Do all bodies have the same inertia? It depends on mass. Okay. So if there is a mass is more, mass of object is more, you can say this. If a mass of this object is more, of course it is more, so inertia will be more. In this inertia will be more because of mass is more. Mass of this object is more, inertia will be more. Now mass of this product is less, so you would say inertia will be less because of mass of this product is less. That's all. Inertia will be less. Clear? It depends on mass. What is the mass of the product? Okay. So the inertia of a product will depend on mass. Next second law of next topic, momentum and second law of motion. This is the next concept, momentum. Word momentum is coming, so here there will be mass. Okay, mass. Okay, so let's understand this with the first question. This is question for understanding momentum. Okay. Now what is it saying? Now here momentum and second law of motion. Two balls of different masses. Uh, Shape of both balls are same, but masses are different. Mass of this ball is what? How much you can say? Uh, gram. Okay, 250 gram. And mass of this how much? 500 gram. 500 gram. Shapes of both are same, but masses of both are different. Are different. From here is what there is a twist. Two balls of different masses traveling at the same speed. A speed is also same. Okay, a speed is also same. Collide with the stumps. With the stumps. These are stumps. Okay, and both ball are thrown towards these stumps. And question is, will they have impact same or different? Will they have same impact or different? Yes, you would say different because of yes, of course, different. Impact of this heavy ball will be more, will be more, and impact of this light ball will be less. So of course, impact of both balls will have different. Okay, will have different. The impact produced by the objects depends on their mass and velocity. Here velocity, a speed was the same. A speed was the same. So here a speed is what? A speed is what? I think it is a scalar. Velocity. Velocity is what? Here is given velocity. It is saying that a ball can go this direction, this direction, this direction. We don't know, but ball will take a direction. That's why velocity came here. Velocity came here. And in velocity is found with a speed. Suppose ball will be thrown with a speed. Yes, it is true that we don't know with how much speed ball is going here. So impact of both balls will depend on velocity and mass. Okay, mass. Clear? Momentum. How to what is momentum? Momentum is represented by p, and m will be represented by a. Mass will be represented by m. Okay, not this by m. Then both will be m. They will get confused. That's why momentum is represented by p. Mass as m, velocity as v. Okay. To find out momentum. Okay. To find out momentum, mass, what is a mass and what is a velocity? What is a mass and what is a velocity? So can you see what is the momentum? What is a momentum? It is the same impact of object. So momentum is what? Product of mass and velocity. Clear? Momentum is what? Product of mass and velocity. So momentum will tell you impact. Clear? What is impact? Impact is high or less. So momentum will tell you what? Impact. So impact will depend on what is the mass and what is the velocity. Velocity is high and mass is also high. Okay, mass is also high. Then impact will be more. Clear? So one thing you have to understand from word momentum. It explains what? Impact. It will explain impact with mass and velocity. Clear? Now next. Next about this second law of motion. So what is that saying? Try to understand. We will understand this together. The rate of a change of momentum. Okay, change in momentum. The rate of a change of momentum of a body is directly proportional to the applied unbalanced force in the direction of force. It is saying there is object. there is a object. Okay. If momentum of a object will decrease, then of course unbalanced force will decrease. Okay. If momentum of a body is being increased, then applied unbalanced force will be decreased. Okay, will be decreased. What I am saying, I am trying to tell you both will increase at the same time, both will decrease at the same time. Okay, if momentum of a body is increasing, then applied unbalanced force will increase. This is meaning of directly proportional. Okay, directly proportional, both will increase. If one is increasing, second will increase also. If one is not increasing, instead it is decreasing, then second will decrease. Okay, second will decrease. We have two balls. One is shape of one ball is greater and shape of second ball is less. Okay, we have two balls like that. Here it is saying we have two balls. Now for the smaller ball, mass will be represented as m. Initial velocity of this ball will be represented. Initial velocity will be represented as u, and final velocity will be represented as v. Time taken will be represented as t. So here try to understand. When this ball, when external force will be applied on this ball, on this girder ball, it will hit this ball, and then now initial velocity of this ball is what? Zero. Clear? Initial velocity of this is 0. Clear? When it will hit this ball, then it will come into motion. So of course it can go in any direction. When it will hit to the surface of this ball, it will come into motion. It means it is taking a speed. Okay, it will take a speed. And with how much time it moved. So here we will write time, that that time that this ball have taken from moved this to the end. Clear? And here F is what? F is a force. When you will remove this proportional, then you will apply equal to K, equal to K. And as you know, P is a momentum, P is a momentum. Here delta is coming. Delta, which means a small change in something, So rate of change of what? Momentum. The rate of change of momentum. As we know, we will write it what? mu minus mb minus mu upon t, time. Okay, now we will get what? K mu minus b t. And as we know, u minus b upon t is what? Acceleration. Can we write? And here k is known as 1. The value of k is what? 1. Okay, value of k is 1. So finally we will get what? M, and this upon this is what? Acceleration. Mass multiple acceleration. So here final velocity minus initial velocity upon t is what? Acceleration. K, value of k is what? Only 1. K is known as a constant. K is what? Constant. So that's how m came what? M is equal to m multiple a. M is the mass and a is the acceleration. Okay. If a word acceleration is coming, it means this ball will have what? Increasing speed, will have a decreasing speed. It will start what? It will start with a speed, and then when it will stop, then it means it is increasing speed. This ball will decrease in speed when it will be stopping, and when it will start moving, then it will have what? It will have higher speed. Okay, that's why we are saying that there is acceleration. There is happening what? Acceleration. Okay, it increasing a speed and decreasing a speed is just acceleration. It's just what? Acceleration. Clear? And how much time taken during this motion is what we will write here. Clear? You can use this formula, you can use this formula. Okay, whatever you want. Clear? So this remember this. Okay, if proportional to delta p upon t, delta p can be written as what? Can be written as mu minus mu minus mb minus mu. Okay, mb minus mu. M is what? Common. M can be taken as a common. M we have taken as a common. Here k is a constant number. K value of k is said, but it is 1. And m will be as it, and v minus u upon t is what? Acceleration. That is all. Clear? From here we have taken m as a common. Here k is 1. We have removed k by taking 1. Clear? V minus u upon t is what? Acceleration. Clear? Not velocity. Velocity is what? if this is a solution, so velocity is what? I think displacement upon time taken. Displacement upon time taken. And speed is what? Distance upon time. Speed is what? Distance upon time. Clear? Velocity will have displacement and acceleration will have velocity. Clear? So can we say this is velocity? Of course we will say u minus v is velocity. U is a final position, u is a final speed, u is a initial speed and v is a final speed. Now next, but hold on. Here, have you seen Fielderman? A person who catch what ball? Ball comes to the Fielderman, and ball is being catched by the Fielderman, and that person will catch how? Like that. Okay. Now here, that person can have what? Ball will come, will hit like that. It will jump. Because ball came with a speed, and the speed of ball was high, and it will hit suddenly on surface of this hand. It can jump. Of course, it jumps. Okay. Now, at the same time, he can do one thing. What? As ball will come, he will catch like that. So here, ball is coming, and he is catching like that. Okay. Here, what is happening? Coming ball is being a speed of ball is increasing when person is catching the ball like that. So here gradually a speed of this ball is increasing, and ball will come in hand. Easily. Okay, easily. But in first person was doing what? Like that, and of course ball was coming with her speed. It will hit on this surface, and person will have what? Person can hurt. Okay, clear? So here, initial velocity of this ball was what? Was something, you can say was high. But as it came at the final velocity of this speed of this ball was decreasing. Yes. That's why it is a definition of acceleration. First, a speed of this ball was high, and you can say was increasing, but at the final velocity, it was increasing. where a speed of a ball was decreasing, okay. Now next, third law of motion. Third law of motion. Third law of motion is very easy. Newton's third law. We are understanding this. This is the final. Newton's third law of motion. It explains that somebody is applying force, and in opposite he will get same force. But remember, magnitude will be same. There will not be any change in magnitude of object. Magnitude will be same. But force will be in opposite direction. So here, for every action, for example, somebody acted. Okay, somebody acted. For every action, there is an equal opposite reaction. Equal. Somebody came immediately and pushed me like that. So yes, the same person will go back. When the person will push me then, and I will also go back. So here magnitude is the same. Magnitude of both objects are same. There is nothing change in magnitude. But force will be in opposite direction. reaction will be in opposite direction. Okay, reaction will be in opposite direction. Clear? These two forces are always equal in magnitude but opposite in a direction. Both will be in opposite. Okay, both will be in opposite. What can I tell you? When we walk like that, when we walk, then here we lift this, and then we lift this side, and then we lift this side. So this is the action. We can this is action, and this is a reaction. This is action, and this is a reaction. Reaction will happen always in opposite direction. Action and reaction act on different objects. Yes, it can happen. Clear?